Hello everyone, let's solve question number 36 of GATE paper CS1 2025. Consider a memory system with 1 megabytes of memory and 16 kilobytes of cache memory. Assume that the processor generates 20-bit memory address and the cache block is of 16 bytes. If the cache uses direct mapping, how many bits are required to store all the tag value? Assume memory is byte addressable. 1 kilobyte is equal to 2 to the power 10, and 1 megabyte is 2 to the power 20. Okay. So we are told that main memory is 1 megabytes, 2 to the power 20 bytes, and cache memory is 16 kilobyte is 2 to the power 14 bytes. Block size is 16 bytes, memory is byte addressable, CPU generates 20-bit address, and cache uses direct mapping. We are being asked that how many bits are required to store tags values in the cache. Okay, so let's first understand what all we require to solve this question. So first we need to know what is a byte addressable memory. Byte addressable memory is simple. Each memory points, each memory address points to one byte. If you have 1 megabyte, that means 2 to the power 20 bytes. So then it has 2 to the power 20 unique memory addresses, one for each byte. Memory address format. Since memory is 2 to the power 20 bytes, you need 20 bits to represent all the possible addresses. If n addressable unit, then log n bits are needed. Okay. So 20 bit addresses can point to any byte in the memory. Cache terminology. So let's talk about, we know what how many bits we know. Now let's talk about a bit of cache terminology. Cache store the data in blocks. Each block here stores 16 bytes. Blocks में data store होता है 16 byte का होता है. It stores 16 bytes. ठीक है? So when data is fetched from the memory cache, it comes in chunk of 16 bytes. Like because block by block we take out. No? So total number of blocks in the cache. How many blocks are there in the cache? Let's understand that. So what is the total memory size? Total memory size was 16 kilobytes, which was 2 to the power 14. Okay. And what is the block size? It is 16. That is 2 to the power 4. So total blocks. कितने blocks हैं? We can easily tell out by 2 to the power 14 upon 2 to the power 4. So you guys know that when base is same, this is the base and this is the exponent. Exponents minus to 2 to the power 14 minus 4 is equal to 2 to the power 10. That is like 1024 cache blocks. So we know how many cache blocks are there. Uh, Now let's understand what the direct mapping cache is. So in direct mapping, each memory block goes to exactly one cache block. एक memory block एक cache block के पास जाएगा. So to find data, CPU splits into three parts: tag, index, and offset. So since it is a direct mapping cache, each block goes to one cache block. Each memory block goes to one cache block. Uh, the CPU splits the memory address in three parts: tag, index, and offset. What is tag? It identifies the block. Index, it identifies which block in the cache. Tag identifies the block from a memory. Index identifies which block in the cache. And offset define choose the byte within the cache block. So it is like this. If I try to draw it, so सबसे पहले tag आता है. Inside that we go to a block. Inside this block, which byte in the cache block. So this is the offset. So it is going like this. So tag में पहले block पता करो किस ब्लॉक के अंदर है विच. ठीक है, पहले ब्लॉक्स पता कर लो कौन से ब्लॉक्स हैं, उसके बाद विच ब्लॉक इन द कैशे एंड देन विच बाइट ऑफ एड्रेस इनसाइड द कैशे ब्लॉक. ओके, सो this is what tag, index, and offsets are. So splitting of 20 bit memory address. क्वेश्चन में ये था ना, तो मेमोरी एड्रेस 20 बिट का है. So let's write that memory address, that is 20-bit memory address. Each block 16 bytes. तो इसके अंदर से मुझे आई नीड टू सेलेक्ट वन. सो हाउ मेनी बिट्स फॉर ऑफसेट? So 16 is basically 2 to the power 4. If I take log, So log of 2 to the power 4. So this is base, this is 1. So 4 comes here. So it is 4 bits for offset. So total bits for offset will be 4. तो हमें offset की bits पता चल गई कि number of offset bits that are 4 basically. ये पता चल गया अपने को. अब क्या करना है? Once we figure out that, let's figure out the index. First, we figure out the block offset. Let's now figure out the index. Then we will figure out the tag. So index basically, we have 1024 cache blocks as mentioned in the question. कितने blocks हैं ये पता चल गए. From that, I need to figure out which particular block in the cache. Okay, which particular block in the cache. So I need to select one out of 1024. So how many bits you need? 10 bits because 1024 is 2 to the power 10. If I take a log again, then 10 will be the answer. So offset bits पता चल गई. Uh, Total number of index bits कितनी होंगी? 10. Okay. Now, what are the tag? What is for tag? So leftover bits, uniquely identifying the memory block. ठीक है. So total address bits कितनी थी? Total bits थी. टोटल मेमोरी एड्रेस बिट्स क्वेश्चन में 20 दिए हैं. ऑफसेट की 4 है एंड इंडेक्स हैज 10. सो रिमेनिंग कितनी हो गई? 6 बिट्स. रिमेनिंग 6 बिट्स आर देयर फॉर टैगिंग. ओके. सो वी फिगर आउट दैट ओके दिस इज. सो ईच कैशे ब्लॉक स्टोर वन टैग वैल्यू ऑफ सेट बिट्स. सो एक कैशे के अंदर एक टैग वैल्यू होता है 6 बिट्स का. ठीक है, 6 बिट्स का. How many bits for all the tag values? How many bits for all the tag value? One cache block stores, sorry, one tag value of set. One cache block store one tag value of 6 bits. ये तो पता चल गया. So how many cache blocks are there? Single. So one cache block unitary method. We will apply unitary method. Store 6 bits. So 1024 cache block will store 6 bits into 1024 is equal to 6144 bits. ठीक है, 6144 6144 bits. So how can I simplify that? 6 into 1024 bits आया था and that is 6 into 10 sorry 2 to the power 10 bits. So final answer will be option A, 6 into 2 to the power 10. Okay, let's quickly summarize that. Main memory is 2 to the power 20. Cache memory is 2 to the power 14. Block size 16 दिया है, so that is 2 to the power 4. You can figure out the total cache blocks from that. That will be 1024. Now inside that, I go in the cache, then the block in the cache, then which byte in the block. This is how we keep going inside. So first let's figure out the offset bits. So offset bits कितनी आएंगी? 4. We get total 4 offset bits. Then we get total 10 index bits, and then remaining bits are 6, which are for tags. So for a single cache block contains 6 bit thing. So for 1024 cache blocks, that will be 6 into 10 1024, which is 6144 bits. 6 into 1024 will be 6 into 2 to the power 10. So option A is the right answer. That's it for this particular video. Take care. Bye bye. See you guys in the next video.